The computer-generated graphic that you're now seeing is a result of morphing the maps of and from the National Geographic Survey. These are the maps which the National Geographic Survey supplies to anyone who seeks them out on the internet. The various ages of our world are labeled. Of course, the National Geographic Survey took into account many different factors. Tectonics, of course, the presence of similar dinosaurs and plants, and divergent landmasses. Once our theory is fully apparent to you, you may find this massive pulling and stretching quite silly indeed. But remember, without knowing that the Earth grew, all the clues lead to this convoluted and swimming about model. These motions are there in an effort to explain the contradictions that we are driven to in order to answer the multitude of conflicting questions which arise. The real, simple answer clears up all these questions. It would sort of have to, wouldn't it? With the theory in place, our map requires no such contorting, warping, growing, sinking and rising of land. If you use our map or globe, these things will make much more sense to you as a thinking person, and all the questions which created this will be simply answered, as you will be able to see with our final demonstrations. Let me assure you that this extreme tectonic movement by the National Geographic Survey is not a joke. This is based on serious study, nor is this simply the view of the National Geographic Survey. This Pangea theory is accepted dogma by all conventional science. This is the worldview for everyone but a very select and perceptive few. Forgive me, then, for the force of my attack. This is rather an uphill fight. First, this Pangea theory is basically flawed. Has been from the beginning. The theory is subject to a basic and profound contradiction. I will attempt to clarify this contradiction, because if I don't, my theory is wrong. Earth's upper, older crust, made easy to recognize by Earth's current water level, covers only about 1/3 of the planet. That 1/3 once covered the whole of a smaller planet. Shallow rifting gave ways to deep rifting and spreading. Lower new surfaces spread and became the deeper, newer catch basins of the planet's water. Before the deep oceans, Earth only had its shallow, warm seas on the land. That 1/3 is nearly 2 billion years old, and in some places older, some places younger. The undersea plate goes from 1 year to only 200 million years old. Most of it is under 60 million years old. That's 60 million compared to 2 billion, or generously 200 million compared to 2 billion. Does this strike you as odd? Look at this undersea map with me. The land masses are, as you can see, firmly planted in and are part of the undersea floor. Oops. The land masses don't float about. Their bases are part of the sea bottom. Welded to it in miles thick of cooled rock, the sea bottom may crack along weak rift lines, and does every day, crack and spread. But the upper continental plates don't move within their undersea plate. That would be impossible. They're attached. They're part of each other, just like your head is part of your shoulders. When these lower plates crack and spread apart, magma fills the gap and the ocean cools and hardens the new magma. This is a new process for our planet. It began about 135 million years ago. It's become very robust and regular in the last 65 million years. Before there were oceans and ocean floor spreads, there were shallow, warm seas between the same kind of rifting spreads we see on the land. These ridges on the land are exactly the same kind of ridge spreading that is under the oceans. They are both part of the same process, except that they are deeper under the ocean, deeper and newer. On the land, these old shallow spreading lands are everywhere. All we have to do is see it for what it really is, ongoing spreading undersea plates, which simply extended outward and deepen to spread and become the oceans. and as they deepened, the old shallow seas drained off into them. And now, on the land, we have left only the shallow sea basins between ridges, which are the spreads. Why don't we see this obvious comparison now? Because now it's all happening under the ocean, except for an earthquake or a volcano here and there. That earthquake spread, since we're talking, let's at least notice how clearly it looks like a small canyon or a small version of a tectonic spread, which it, in fact, is. Think of it. No oceans. Let's do some conservative math. If the Earth's oceans, Atlantic and Pacific, spread a combined 4 to 12 inches per year, as science says, we'll take the growth figure at a mean average of a conservative 6 inches a year. We'll take that growth or spread over 200 million years. That's a seafloor growth or planetary tectonic growth of 8,590 miles in just 200 million years. The circumference of the Earth is 24,902 miles. This means in simple conservative numbers that the Earth grew a full 1/3 of its circumference in the last 200 million years. That's over 1/2 of the Earth's volume. More importantly, perhaps, is that this growth was in the ocean only. Let me point out that these are very conservative figures. The reality is that the Earth's circumference doubled in the last 100 million years. Boy, say that one over to yourself. Doubled. Let me explain exactly how tectonic rifting and spreading happens in a simple graphic form. This is Planet Joe. Planet Joe is growing. Planet Joe has always grown. We've caught him at an interesting time. Planet Joe has only recently cooled his outer skin, otherwise known as his upper tectonic plates, so that the plates are firm and solid and quite thick. Even so, Joe's a growing planet, so his new shiny, thick, dry skin cracks and spreads apart like an eggshell. As Planet Joe grows, that outer shell seems to spread apart, but the pieces themselves aren't moving at all. They just move outward on the lower growing surfaces. Notice as they move apart, it becomes harder to see how they once fit together. Curves on the growing globe stretch and flatten and crack at the edges. Notice also, as the pieces recurve to a bigger planet, their centers collapse and wrinkle into folds that we call mountains. Notice also, in time, even the lower plate thickens, and the rifting and spreading goes even lower. These new cracks do not exactly follow the same cracks as before, making putting the pieces back together again even harder. The pieces seem more random. Of course they're not. But there is no subduction. No piece rotates, or shrinks, or grows, or moves around the planet. The pieces don't travel. The pieces stay where they are. The planet grows.